It's hard to make sense of this question. But however, if we bring the negative terms to the other side, now this looks like an exponential function, right? So if x is equal to 0, you get 1 plus 1. We're at 2. Okay, when it's 1, you get 3. And in fact, this has a horizontal asymptote at y is equal to 1. So it's an exponential function that looks like this, roughly. Now y equals 3x. Y equals 3x is a line with a slope of 3. So it'll actually pass through the origin, and it'll also pass through this line here. Okay, so definitely x is equal to 1 is a solution, right? They intersect there. You plug in 1, you get 3 minus 2 minus 1. It does satisfy the equation. Let's just see what happens if x is equal to 2, for example. Okay, for this, you get 2 squared plus 1, which is 5. For the 3x, you get 3 times by 2, which is 6. Okay, so what that means is that after this intersection, at 2, the line actually happens to be higher than the exponential function. It's doing this. It's going under. Okay, let's check another value. Let's check 3. Let's see if the exponential function will still be below the line. So y is equal to 2 cubed is 8, plus 1 is 9. 3 times 3 is also 9. So in fact, at 3, so 1, 2, at 3, it's going to intersect each other one more time with the line. And then actually beyond that, the exponential function will grow faster. So the exponential function almost always, I shouldn't say almost always, as x gets large, it's always bigger than the linear function. So once the overlap happened here, okay, there's overlapping, they meet, and the exponential function now is going to grow a lot larger. Okay, you can confirm that by plugging in 4 and 5. You can see the difference will just widen. Okay, they'll just get bigger and bigger and bigger. So I'm saying all this because this means there can only be 2 solutions. 1, and the other one has to be 3. Beyond that, okay, the exponential function will always be above the line. So these two are the only solutions.